All right, so here we are with our next lecture in this series of fun, and we're talking about organic chemistry today in class, and I wanted to make sure that we were on the same page and review a couple of concepts that were toward the end of the class, and we were naming some basic hydrocarbons, that means carbon and hydrogen in the same chain, and what I want to make sure that we're on the same page about is how to name these hydrocarbons, okay, that have different substituent groups being attached to the carbon chain. So for instance, as I showed you today, I have this carbon chain, and we know that there's 4 carbons here. So it's meth, eth, prop, and bute, and I'm getting that from table P, or you should have that memorized if you're from a different course. And there's single bonds between the carbons, so this is an alkane, it's saturated, but I have something attached to the carbon chain here. So as I said, I'm attaching a Grodsky, so we attached an Grodsky here. And we have a Grodsky on which carbon? Because again, isomers have the same number of carbons, hydrogens, in this case Grodskys, but they're going to have a different place where they arrange their elements or Grodsky. So we need to have a naming system that tells me exactly where these things are attaching to my carbon chain, because believe it or not, they will affect the chemical and physical properties. As I showed you before, isopropyl alcohol, same chemical formula as propanol, but one is deadly and one is not. Okay, so naming this, the first thing we look is the carbon chain, the longest continuous amount of carbons. This is 1, 2, 3, 4 carbons. They're single bond. So I know this to be a butane, okay, and that's why the butane pops up here. So the bute is 4 carbons, ane is single bonded. That's a butane. Notice the 2 Grodsky. Why is it 2 Grodsky butane? Because Grodsky's on the second carbon. Now, if you name this the longest continuous carbon, you can name it just 2 ways, really. 1, 2, 3, 4, or 1, 2, 3. So if you put 3 Grodsky butane, you'd get that wrong, because just by convention, how we decided, we're going to name this substituent group on the lowest carbon possible. Okay, so that's how it works. We have the carbon chain, easy to name, how many carbons and what kind of bonds are between them. Then we have attaching groups where we have to make some significance to where it's located. So on the second carbon of my butane, I've got a Grodsky. All right, moving forward, maybe. All right. We have adding substituents to a parent chain. So now, okay, I've got what kind of carbon chain? I've got 1, 2, 3, 4, 5, 6. Now 6 is a hex. There's single bonds between the carbons in the structural formula, so it's a hexane. Now what's attached to the hexane, we're going to add a Grodsky. Okay? Yes, but where is Grodsky located? The first thing I do is count the longest continuous chain of carbons, and we get 6 because it's a straight chain. And we're either going to get 1, 2, 3, the third carbon Grodsky is attached to, or we get the 1, 2, 3, 4, the fourth Grodsky, the fourth carbon Grodsky is attached to. So which one is it? Well, it's the third. Okay, what's the difference? Well, we decided in the IUPAC naming system to give the lowest number carbon, okay, the number. So we're going to count this as the third carbon. So our name is, you got it, 3 Grodsky, and our chain is hexane. 3 Grodsky hexane. If you look at your shampoo bottles next time you bathe, no matter how long that might be, okay, you'll see that there are numbers and names associated to where certain things are attaching to a carbon chain. Okay, I dare you to look at it. Dare you. Okay, moving forward. Now we have things that aren't Grodskys attached. We have something called actual other carbons, methyl groups. Meth means 1 carbon from table P. That could be attached to a carbon chain. And we can have a 2 carbon group called an ethyl group. In truth, we can have a propyl group, okay, a 3 carbon chain. What makes this confusing is, well, if they're all hydrocarbons, it's easy to spot where the Grodsky is with the hat and the funny face, okay, or the silly face or the ridiculous face, okay? And it's easy to find where he is, but now they're all blending together. So you really have to look at your longest continuous chain here. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Yeah, so 6 is the longest. Now, some people might say, well, 1, 2, 3, 4, 5, 6, 7, there's 7 carbons here. They're all single bond. And hey, that's a heptane. That would not be correct. The longest continuous chain, you might want to circle it and everything attached to it. Now, people say, well, how do I know there's single bonds? Well, if it's CH3, okay, if it's CH3, C, and you have what? 3 H's attached, that's the ending one. And of course, if there's one bond here, it's just, I don't know why it's linked now, CH. So the middle carbons have to be CH, CH2. That's why you see these CH2, and the ending ones are CH3. So if you draw it, you'll see carbon having 4 bonds, and each of these CH2s are the middle ones. Or if you don't like any of that, okay, then what you can do is you can hey guys, you can just count the carbons. 1, 2, 3, 4, 5, 6, 7. C7H what? Well, CnH2n is the formula for an alkane. H2n plus 2, I should say. So CnH2n plus 2 gives you 7 times 2 is 14. 14, okay, plus 2 will give you the 16. If you count the H's, they'll equal to 16, and it's another way to check. Okay? Okay, so as we've seen already, okay, naming this long chain hydrocarbon, we do so by numbering the following. So we would follow the numbering system so that we have the longest continuous chain numbered in a way to give us the attaching group the shortest number. Okay, we can see this is the 5th carbon, okay, and this is not correct. That's why you see this rock off here. And so we have to number in a way so that the carbon with the attaching group has the lowest number. So this is a 1, 2, 3, 4, 5, 6. This has a 6, okay. So this is a hexane. You don't count this carbon because it's not part of the longest continuous chain. So it's a hexane, and we have a methyl group on the 2nd carbon. So this, of course, is 2-methylhexane. All right, 2 for the carbon that the methyl group, the 1 carbon group, is attached to the hexane, the longest continuous chain. We put that group that's attached to the longest continuous chain the lowest number possible. Okay, and here's another one to name if you look at it. Okay, this is one way to number them so that we get the what? The carbon. You may say, Mr. Grotsky, why isn't it 1, 2, 3, 4, 5? And a pentane, because this could be a methyl group attached to a pentane, because the first rule is the longest continuous chain. Longest continuous chain, of course, is 1, 2, 3, 4, 5, 6, not 1, 2, 3, 4, 5. So you have to count the longest continuous chain. And remember, these things don't have to be written in a straight line. They could twist and turn through their single bonds, as I showed you before. So the methyl group's on the 3rd carbon, so we say it's a 3-methyl, and of course the parent chain that it's attached to is hexane. Very simple. Okay, here's another compound, and we can name them this way. And notice I put the numbers in that give me the what? The carbon on the methyl group attached to the longest continuous chain, which is a hexane. And notice the methyl group is also at the 2nd carbon. And there you go. It's a methyl group. Again, some people might say, hey, that's 7. It's a heptane. No, no. Longest continuous chain. Whether you count this one or this one, this would be a methyl group. If you go 1, 2 and make this the methyl group, it's not going to matter. These things kind of swing in the same positions. If you notice, the same name as the other compound. So hexane for the longest continuous parent chain or hydrocarbon chain, and the attaching group is on the 2nd carbon, the lowest carbon there. We have the methyl. So that's how it works. How about this one? Okay, so we have a cyclo compound. Notice if we count the corners, that's the carbon backbone. The H's aren't written. We're going to have a hexane, and we have a 2-carbon background, so we have an ethyl group. Eth means 2 carbons in table P. So ethyl cyclohexane. Okay, names are getting pretty big, but the name describes the structure. Okay, Oops. Okay. Now, when more than one of the same attaching group to a hydrocarbon, you have to identify where and how many exist. So here we have two Grodzkis coming in, and these two Grodzkis are attached where? They're attached on the first, second, third, and fourth carbon, or the 1, 2, 3, 4, 5, 6. Is it 3, 6, or is it 1, 4? Now we have combinations of numbers. Which combinations give me the lowest number? 1, okay, 4, or 3, 6? You probably have guessed it. 1, 4 is what we use. Now because there's two Grodzkis, we have to add the word di. Okay, di means two, so 1, 4 digrodzki, and then here comes the parent, or the longest continuous hydrocarbon chain, and there's your hexane. Okay, and that's how that works. All right, so let's look at one example, and we'll get to the work of home. Look at this example. The first thing to look at here is the longest continuous chain. The longest continuous chain is what? Meth, eth, prop, bute. 1, 2, 3, 4, 1, 2, 3, 4. I can't count a continuous chain any longer than a 4-carbon hydrocarbon called a butane. So this is a butane. Let's go across. If you got a butane, where are the attaching groups? Well, again, it might be easy to do this. I'm going to make this my parent chain, or my hydrocarbon chain, and I have a what? A methyl group attached to this carbon, another methyl group attached to the butane. Okay, so what we have is 2,3-dimethylbutane. On the second and third, count with me. 1, oops, bad Grodzki. Count with me. 1, 2, 3, 4. On the second carbon, I've got a methyl group, and the third carbon, I've got a methyl group. No matter how you want to count it, it's 2, 3. The di is because there's two different groups. If there was 3, we'd use tri. If there was 4, it's tetra. So you can see this naming system is being built upon the structure. Okay, that's as far as I want to get here. Okay, and I want to go to questions 1 through 6 of your other alkane naming sheet. We're going to go there now. Okay, here we go. First one, A. Okay, let's see here. CH3, CH2, 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 CH3. Okay. Now you may say, Mr. Grodzki, how do I know that's similar to a bond? Well, draw your Lewis structure here, and you'll be CH3, C2, 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 CH3. For carbon to be single bonds, you need 3 C's at each end and C2s, or you can just do the chemical formula, see if it fits the CnH2n, 2n plus 2 rule, and it does. Okay, there's 1, 2, 3, 4, 5, so it's C5, and there's 10, 3 plus 2 is 10, there's 12, H10, H12, so that fits an alkane formula. So here we go. So this is a straight chain alkane. You can put N in front, but it's easy to say, listen, that is 1, 2, 3, 4, 5. That's a pent. And because they're single bonds, we add ane. As simple as that. Some people put N-pentane for straight chain. Okay, but pentane is all you need. Okay, here is where we have to start counting. Okay, I'm going to count this as the first, second, third, and fourth carbon. This is also an alkane, only because it's an alkane naming worksheet, but I can see that carbon is going to make 4 bonds. 1 to another H, 1 to another C, 1 to another C. So this is a little confusing what's happening here. We have a carbon bonded to another carbon, and bonding to a CH3. This is bonded to another CH3, and there's an H here. So you can clearly see that this is a single bond as well. I was just drawing this structure right here. So that's an alkane. I know it's an alkane naming worksheet, but you should be able to visualize that nonetheless. And of course, if it fits the CnH2n plus 2 rule. And it does. Okay, so it looks to me like I have 4. That's a bute. Okay, meth, eth, prop, bute. They're single bonds, so it's a butane. Now, the question is, what's attached to the butane? Because this is my longest continuous chain here. I've got a butane, but I've got something in front. I've got something attached to it, and that's a methyl group. So I have a methyl group, and it's on the second carbon, so it's 2-methylbutane. Let me rewrite that to make that a little bit nicer. So this is going to be 2 dash methyl butane. Okay, and it's on the second carbon. We got an attaching group, a 1-carbon group. Okay, over here, longest continuous chain. 1, 2, 3, 4. Looks like another butane. Okay, so this butane, I'll put over here to give myself some room. But here you have 2 methyl groups attached to the same carbon. Okay, this is new. So we know we're going to have a dimethyl. That's what we talked about today. Di means 2, so it's dimethyl. All right, longest continuous chain is clearly 1, 2, 3, 4, no matter how I do this. So I have a dimethyl butane, but I need a number to associate it, and I can't just say 2. 2-dimethyl butane just tells me where one of the methyl groups are. But I've got 2 of them. By saying 2-dimethyl butane, and I'm reading this and I'm trying to figure out what the structure is, I do not know where the second one is. So because they're on the same carbon, the second carbon, I don't pick the third because I want the lowest number, it's 2, 2-dimethyl butane. Right, every attaching group has a number. Next one, we need a longest continuous chain here. So for me, sometimes I like to draw these and see that this looks like the longest continuous chain. And that gives me what? That gives me 1, 2, 3, 4. Let me zoom in here. So 1, 2, 3, and 4. And on the second carbon, if I count the other way, 1, 2, 3, this will be the third carbon. So it looks like to me, I have a methyl group attached to the second carbon. All right, so I have 2 methyl methylproputane. Okay, easy. On the second carbon of my butane, it's single bonded. Okay, I've got a methyl group. Okay, and now we're going to get some challenges going on here. Where is my longest continuous chain? Well, if I go 1, 2, 3, 4, 5, 6, okay, or 1, 2, 3, 4, 5, 6, no matter how I count, 1, 2, 3, 4, 5, 6, 6 is the longest continuous chain, and it's a hex, and if you count the C's, it's a hexane for single bonds. Now, what do I have attached to this? Now, if I count the way that I just did, and you certainly don't have to, but I'm just showing you how you can look at these things differently. This is my longest continuous chain. Don't fall in love with the fact that it has to be straight across. 1, 2, 3, 4, 5, 6. So this is going to be your hexane. So my longest continuous chain is my hexane, and what's being attached with it? Okay, well, I have 2 carbon groups, one on the 3 and one on the 4. And if you know, if I count the other way, 1, 2, 3, 4, it's not going to matter if this is the third or this is the fourth, because I have something called an ethyl group, right? 2 carbon group, that's an ethyl group. And I have 2 of them, so guess what? It's diethyl hexane, but you got to give me where they're attached to. And you've got it, 3, 4 diethyl. You got to tell me a number for each one. Okay, D is pretty simple stuff here. Okay, ethane. Okay, 2 carbons, ethane, single bonds. All right, did we do 3? Yeah, that's enough. Okay, that's where I want to stop tonight. Okay, we'll pick this up tomorrow.